Hi, welcome back to our channel and back to the tutorial for deep learning. Today we're going to discuss the basics of fast arch engine. So before going that basics of fast arch engine, we are now what is object direction? So object direction is nothing but that is finding and classifying the object in the objects in the given image. So these are the basics. So as of you know, I have arch engine. So this tutorial we are going to see the just basics of what is fast arch engine and what are the components or key aspects of uh, RCNN and architecture of architecture, and later we can go for implementation also. So here, what you can understand from RCN is one of the variant where developed and based on the RCNN only, basic RCNN. Moreover, is one of the basic deep learning method, object direction model, and follows the two-stage object direction model here. That means it follows all the two, two stages. Moreover, the advantage is it will additional add the regional proportional network for identify and localize objects in real time also. Moreover, whatever the data and whatever data you're going to give, it can analyze and respond very fast based on the speed also. Most because of RPN generates the boundary box concept here, the candidate box here, or anchor boxes also. For the field of computer vision, it's very important because the fast assessment were merging the concept of future extraction, region proposal, and classification where to a single unified framework also here. Some of the key aspects of architecture is backbone network, regional proposal network, and ROI and direction also. So we can use this kind of faster RCN along with a pre-trained model like VGG16 or ResNet or anything. Moreover, transfer learning also. And backbone network because it always follow the pre-trained CNN model like ResNet or VGG, just I told you, for extract feature maps from the entire image also. Then RPN is there, it always scans the feature maps and predicts the objectness scores and boundary box using the anchor boxes. For network, it will say to network where to look. That means wherever the object, it gives the information. And what are the object, and later go for give the information with the classification of object also. For example, take some images like animal data set, where is the dog, or else you can refer where is the cat like that after training only. Then there will be ROI pooling and direction is there because it always extract pixel size feature vector from the region to classify object and accurately refine their boundary box also here. After getting implementation, you can get more data here. So before that, you had now the difference between the RCNN and fast RCNN and fast RCNN. So we are going to discuss the basics of fast RCNN only. So RCNN is there because it has some limitation. That means it's one of the deep learning model where improved direction accuracy is there somewhat better only, and also follow the selective search method to generate approximately 2000 region per image here. And then fast RCN is that these are developed after the RCN in the year of 2015. It also processes the entire image wants to create a shared feature map and ROI pooling concept also. Then faster and more efficient and drawback is still depends on selective search for region purposes and limiting speed. So for your entire network or custom data, you can design and even design something. What happened? The fast RCN gives slower performance only. That reason we are moved to the fast RCN, very speed and convenient and region with the help of RPN, it support also. Here it's an RPN where uh, lands region proposal and object direction quickly also. And also it improves the direction speed and accuracy more and eliminate the need for selective search also. Then the one drawback is there will be a single stage direction like computationally intensive. That's a small drawback. Let's move the architecture. So once come to the architecture, we have four components. One is called backbone network, another called region proposal network, another one called region of interest pooling or direction network. So first one is the backbone network because just told you because a deep CNN like VCCN or ResNet used as a used for future extraction. Moreover, it translate or convert the input image to a feature map here. And these feature maps are later shared by the RPN and direction here. So here now the meaning of what is feature map. So feature map is nothing but these output images where created are generated by the convolution layer of the CNN after applying filter in through the input image only. Moreover, with what you can do with the feature map because it helpful to highlight important patterns like edges, texture, and object parts also. This helps the model or network to recognize the object very easily. Then region purpose network. So if you come to the region purpose network, the architectures look like this only. Later go for deep discussion with implementation. So here what you can understand, there will be one small sliding network is there that operate on the feature maps only, based on the feature maps. Already so anchor box is there. These are generated by RPN. Then it also predicts the object score and refine boundary box coordinates also. Then it utilizes the anchor box of different scales and aspect ratio for create and generate or generate region purposes efficiency here. Then region of interest. So this assume that there will be object car like that. So it will go for our ROI pooling is there. After ROI pooling, the convolution layers, everything what applied extraction then give you the final answer here. So it here generally these are translate or convert the proposed region of various sizes into a fixed size feature map for direction network. Because the deep learning models always need the future map with fixed size only. For this reason like converting here and it's also ensure uniform and standard input size for fully connected layers here. The direction network. Here, just now, let's assume that there will be car. This is predicted the probability of 0.98 and softmax layer applied, fully connected layer applied here. And at last, we can view the output here with the help of the RPN, then classification also boundary bus also. Here what you can understand here, it generally classify each proposal region into a object categories and also refine the boundary box for accurate localization. So there will be a object is these are boundary boxes there. Remember, so boundary boxes there wherever the object it go on the box it. Then it uses a softmax layer for classification and smooth alone loss for boundary box recognition here. So this is very important because once go train the model and get the output should be visualized easily. So here you have now the meaning of L1 loss, that is nothing but one of the commonly used boundary box regression, wherever it measure or give the relationship between the predicted boundary box coordinates and the ground truth boundary box coordinates here. So suppose if you train the car, it will suppose if you train the car and after giving input as a car, it will go on direct. Suppose if you train the car, if you give some other vehicle like that, scooter like that, it may predict and say not match like that. So if it are matched objects come, it will give the clear answer. Then the model help to minimize the loss. So the predicted boundary boxes closely match the actual object location. So this is an example. So car is there. Probability is here. Score is 0.98. Almost correct. Should showing the accuracy like that. So these are about the basics of fast Artinan. So today in this tutorial we learned what is fast Artinan and we need fast Artinan and we compare with the some other models also. Thank you for watching video. Upcoming session we check the implementation. And if you like the video, please subscribe and share with your friends. Thank you.